Hello, everyone. In this episode, we'll look at GAN application of fraud detection using anomaly detection using plain GAN. Let's go to the code. So GAN is good at creating synthetic data that is very realistic looking fake data, isn't it? So we show here how to use that for anomaly detection in credit card transactions. And what we'll do is that we'll basically have the GAN to train non-fraudulent transactions. Um, um, so that the generator learns to produce realistic looking normal transactions. And then when we take that model, trained model to real and fraudulent data, normal and fraudulent data, well, the discriminator or the critique will basically score high for the normal transaction, but for the fake data it has never seen, will basically give a very low score and will say it's um, fake data. All right, so the step is load the credit card transaction, explore the data, prepare the data, build a GAN using normal transactions. So that is important, normal transactions only. Um, and then use the train discriminator as a fraud detector. With low score, when it thinks that's fake, that's likely fraudulent um, transactions. Okay, and we use the Kaggle data set um, of the credit card fraud detection. Okay, so first mount the data and load the libraries and all these TensorFlows. And we basically already have from Kaggle download the data and it's on my Google Drive, the credit card.csv. And if you look at it, it has 28 columns and the amount and the class. Class being 0 if it's normal transaction, 1 if it's fake transactions. There are, of course, a lot more normal transactions than fake transactions. So if you look at here, how many fraudulent, there are only 492 fraudulent transactions and 10 more than 280,000 normal transactions, isn't it? And by the amount, I guess the fraudulent amount are very small amount. The normals are really distributed here. Okay, so here are various variables of the normal and fraudulent transactions, and this is the pattern that the GAN will try to learn from the normal transaction data. First, time is kind of irrelevant. We'll drop it and scale the amount column and split normal and fraudulent data um, so that we train only on the normal transaction, at least for the training data. So for the test data, we keep both normal and fraudulent transactions. And then have the train test splits. Okay, so drop the time column, and so we are basically cleaning up the data and split the normals have fake transactions here. Um, so, and then the GAN architecture, it's not too much surprising. We'll basically use a neural network, a deep neural network. Um, so whatever the input dimension is, 28 or 32, okay, and it goes to 128, 256, 128. And then goes to the output layer. How many features? 29 features, okay. Um, and then the latent dimensions from here, okay. And then the discriminator is taking a realistic input data. So how many features? 29 goes to 256, 128, 64, and then 1, which is basically whether it's a real transaction, then 1, 0 if fake transaction if it thinks, okay. So this is the discriminator and the GAN. It's basically combining the generator and discriminator. Of course, the discriminator is kind of weights are frozen. It cannot be trained. Only the generator weights are trained in the GAN training. And then, well, some helper functions like real samples to generate for training. To get the generator started, we need random seeds, so generate latent points, and then to generate the fake samples using the generator. Okay, and then evaluate the detector. And then here we train the GAN. Um, not too much surprising. Get real data and then train on real data. Get fake data, train on fake data. Um, um, and then the GAN actually generate latent points, put into the GAN, um, have tell that it's actually true data. So we try to fool the discriminator and then train the GAN on that and get losses and periodically plot it. Okay, so I've trained it in advance. So if you train it, you can see it's for 5,000 epochs. You could train more, but I'm not hopeful because you can see that the average precision is kind of stale. The gun probably didn't do too much of a great job. If you look at the visualization of it, it kind of generates the losses decreasing, discriminate the losses increasing, but the fraud detection is basically flat. Okay, so if we use the discriminator to filter out normal transaction and fraudulent transactions, the mean anomalous score is slightly higher than the normal transaction. The fraud transaction should have higher anomaly scores, but it's not really too much, isn't it? So I'm not optimistic about it. Um, so, and the ROC curve, which should look like actually look like this pattern, but it's not. So it probably didn't do too great job of it. And you can see the F1 scores also not too great. Um, and if you look here, the confusion matrix. Um, so here, so out of the 490 to fraudulent data, it only truly detected 100 of them and missed like 390 of them. That's probably not too great. And if you look at just a simple autoencoder, and I trained and then do the same thing, do an anomaly detection, it actually, you can see that autoencoder performs a lot better in the ROC curve and many things. In fact, if you look at here, AOC GAN is 54% and autoencoder is 92, 93%. So you can see the plain GAN basically didn't do. What might be problem is that the mode collapse or something, that the vanilla GAN is known to not perform the best always. So it's kind of unstable in training. Um, so we need some improvements on this, which is the next episode's concern. All right.